Hello everyone, my name is Mridul Swarup, a developer advocate here at Vulture. In today's Tech Talk, we are joined by Humphrey and we are going to be discussing how to generate images using Stable Diffusion.
Hello there, Humphrey Pyre here, and I'm a developer advocate at Vultr. In this Tech Talk, we are going to discuss generating images with Stable Diffusion, which is an open source alternative to services such as Midjourney and OpenAI's DALL-E that allow you to create stunning images from prompts. As mentioned, Stable Diffusion is a deep learning generative AI text-to-image model that produces photorealistic images from prompts. It's actively maintained by Stability AI, based on diffusion technology, and apart from simply generating images from text-based prompts, it allows you to generate an image by providing another image as the input with a guidance prompt to make modification to the source image. So, using Stable Diffusion, you can build applications with image generation capabilities. Depending on your use case, you can modify all parameters and take charge of the image generation process, which might not be possible when using closed source models and APIs. So, there are multiple iterations of available Stable Diffusion models. This starts with the very first best Stable Diffusion model, also known as version 1, followed by Stable Diffusion version 2, and the flagship of the class, Stable Diffusion XL. They all provide similar functionalities, but with slight improvements to the final output image as the versions do progress forward. Apart from these best models, there is also a large number of fine-tuned Stable Diffusion variants, such as OpenJourney. These fine-tuned models allow you to generate images of different styles without having to engineer the original prompt to match your style. By this standard, the major Stable Diffusion use case is text-to-image generation. In this method, the model generates a matching image based on your input prompt. To generate the best possible images, you can provide a pair of prompts that include a positive prompt, which guides the model to generate images based on your provided keywords. Then, a negative prompt discourages certain characteristics from showing up in the final output and also guides the generated image focus. Image-to-image generation allows you to provide a base image, and Stable Diffusion generates a modified copy of the image depending on your input text prompt. Just like text-to-image generation, you must enter a supporting text prompt that describes the final image you'd like to generate. In the example Stability AI image on your screen, a best image is supplied with a transformation prompt. Each time a new prompt is served to the model, the image is transformed better and better to generate a high quality result based on the previous copy. Video and GIF image creation operations are also supported by Stable Diffusion models. This way, you can generate high quality images and videos from text prompts. A popular use case is a D-Forum open source platform that plugs directly into Stable Diffusion to produce quality videos using your GPU server resources. To make use of the latest model versions, you can find Stable Diffusion models on Hugging Face and GitHub. Hugging Face hosts a vast collection of open source Stable Diffusion models and other AI ML models you can implement in your production applications. Depending on your desired Stable Diffusion variant, view the model page instructions to successfully deploy it and use it in your applications. On the other hand, GitHub offers a wide range of fine-tuned Stable Diffusion models that are directly forked from the parent repositories with improvements to provide more customization and extension with advanced image generation capabilities. So, if you are looking for fine-tuned Stable Diffusion models, GitHub is the perfect location to find a wide collection of solutions you can implement in your applications. By licensing style, Stable Diffusion models are distributed with the Creative ML and OpenRail licenses. These licenses permit you to commercially use and share any images generated using Stable Diffusion without crediting the model generation process itself. This means you do have full control and full ownership of all images generated in your sessions. To inference and integrate Stable Diffusion models in your existing applications, you can either use the Vultr Evoke AI marketplace application that allows you to experiment and generate images with different Stable Diffusion model variants. You also have the capability to manually upload a fine-tuned Stable Diffusion model of your choice to generate high-quality images that match your intended resolution and application needs. On the flip side, One Diffusion allows you to create a plug-and-play API to add image generation capabilities to your existing or new applications. Basically, An API helps you to integrate these models independent of the application language code, middleware, underlying infrastructure, and so on. You can also go with the programmatic route if you want to integrate these models deep into your application. You can import the models required to create the model pipeline that can be used to generate images by providing prompts and parameters such as the dimensions of the image you would like to deploy. To experiment and generate AI images with Stable Diffusion, let me take you through a demo that implements the Evoke AI, One Diffusion, and many programmatic methods on a Volta Cloud GPU server. To experiment with Stable Diffusion models using the Volta Evoke AI Marketplace application, access the Volta customer portal and log into your account. Within the Cloud Compute Product category, click Deploy to create a new server. Choose the Cloud GPU category. Scroll and select the NVIDIA A100 GPU type since it's the best version that enables smooth AI model operations. Scroll and select your desired Volta location to deploy the server to. For my case, I'll choose the London Volta location. Within the server image group, find and select the Evoke AI Marketplace application. Choose the server size of your choice depending on your budget and planned traffic workload. And for the best model results, please choose a server with at least 10 GB of GPU RAM. Click Deploy Now to create your new server. When the server status changes to running, click the instance to open the server control panel. Scroll to the App Instructions section within the Overview tab and keep note of the generated username. Select and copy the generated password to your clipboard. Then click the Evoke AI URL to access the application interface. So within the Evoke AI interface, enter a text prompt of your choice, for example, Lion King of the Jungle. Click the Evoke button to start generating your image based on the prompt. Watch the image generation process as Stable Diffusion works through the model process to render your image. And now, as you can see in my output, a fresh Lion King image is generated. This is fair enough, but in case you would like to fine-tune your result, simply fine-tune your prompts, apply a negative prompt, and make sure that the model can get the best focus as possible to give you a high-quality image. It's also important to know that you can generate images with Stable Diffusion using One Diffusion. What this does, it enables the deployment of different models in a production environment. To get started with One Diffusion, access your Volta Cloud GPU server using SSH, preferably as a sudo user. When logged in, install One Diffusion using the Python pip package manager. When complete, let's view the One Diffusion homepage to verify that the application is installed correctly. And as you can see in my output, One Diffusion is able to run correctly. By default, One Diffusion will listen for incoming connections on the TCP port 3000 unless you change this in your configuration. So let's allow the port through your current firewall table to enable access to the web interface. Now, let's start One Diffusion with the default Stable Diffusion 2 model. So wait for the model to download to your server, and when the process is complete, open a new web browser on your computer. In your web browser window, access your Volta Cloud GPU server IP on port 3000 to access the One Diffusion interface. Within the interface, click Post in the Service APIs group and click the Try It Out button. Replace the default A bento box prompt with your desired prompt. For example, let's use astronaut riding a horse in a photorealistic way. And so when the process is complete, you can come right here in the response body and click Download File to download the generated image. And now, as you can see in my output, we have generated an astronaut image. And so, just like that, you can always alter your prompt to generate your desired image quality using the One Diffusion interface that you can feed direct to your application API to generate high quality images for your production needs. Another way through which you can create AI generated images using Stable Diffusion is the manual programmatic way. We shall follow the instructions in the Volta Docs resource linked in the description of this video. Within your Jupyter Notebook session, install the required dependency packages using pip, declare the model, define a new text prompt with your target keyword to serve to the model. For example, astronaut in a jungle. View the AI generated image from the model. And as you can see in my output, we have a fine AI generated image of an astronaut in a jungle. You have generated AI images using 3 different methods: the Volta Evoke AI Marketplace application, One Diffusion, and the manual programmatic implementation with Jupyter Notebook. So today, we have discussed AI-generated images using Stable Diffusion models, how you can find them and implement them in your production applications using Volta Cloud GPU servers. Thank you for tuning in to today's Tech Talk. Please feel free to subscribe to watch other exciting upcoming Volta Tech Talks. Until then, thank you for watching.